Today's energy grid is evolving faster than utilities can adapt. Data centers, EV charging stations, rooftop solar, and sensitive electronics all place new stresses on infrastructure. As demand continues to grow, issues with power quality and aging infrastructure only further complicate these challenges.
Our electric grid is really aging. A lot of it is over 75 years old and needs to be replaced. It's one of those things that we rely on every single day. It powers our homes, it powers our phones, and so we really need it to be up and running 24/7. Now, at the same time, we're facing a lot of catastrophic weather events.
Issues like voltage distortion, imbalance, and voltage sags are a real challenge for utilities because they're subtle. They don't cause immediate problems in many cases, but they cause gradual degradation or incompatibilities with customer equipment. And that data is often difficult to find in thousands of waveforms and strip charts.
The grid was not designed to meet the increased demands of a restructured electricity marketplace, the energy needs of a digital society, or the rising use and variability of renewable power production. Power Monitors uses extensive field monitoring and data analysis to help utilities quantify how these factors impact system stability and reliability.
Power quality issues really have a direct impact on business operation and productivity, especially in the industrial space. A single voltage sag can bring down a factory line and cause a reset of that continuous process that can take hours, even days, for the manufacturer to restart that line. And in the commercial space, power quality issues like voltage swells, voltage sags can cause electronic equipment disruption or damage.
The PMI's equipment allows us to remotely monitor our power quality investigations. Operationally, this helps as we don't need to send a crew out to a location to receive the latest power quality data. Instead, from a web browser, we're able to access the latest power quality information on the devices we deploy.
The workforce is also in transition. As experienced engineers retire, utilities face a shortage of personnel with deep PQ expertise. Researchers and engineers at Power Monitors work closely with utilities to develop methods that streamline analysis and preserve expert knowledge through better use of data.
The growing complexity of the power grid has certainly been a challenge. We're seeing new and unusual types of customer load, as well as distributed generation that we haven't seen traditionally. With the lack of skilled engineers in this field, it's difficult for us to keep pace with the new issues that we're seeing. The data we're getting back from our power recorders is exploding in data that we just can't go through by hand.
Utilities are really in need of tools that are force multipliers that allow a small number of staff to keep track of more and more data and just spot more and more patterns. The problems they're trying to find in terms of power quality are subtle and require really an analysis of every single piece of data that comes in, and there's just not the bandwidth to do that. And so if they have tools that are kind of the first eyes on that can do the triage and put together narratives for utilities to understand what's happening, that's a great time saver.
Reliable, high-quality power isn't just an engineering target. It's essential to business performance and grid resilience. Power Monitors also focuses on how artificial intelligence can be applied to power quality data to help utilities move from reactive troubleshooting to proactive, standards-based management.
A typical power quality investigation starts with a customer complaint. It's reactive. Something has happened. What we want to do now is move to a proactive, where you can detect things beginning to go wrong, where you can see things slipping, not past the standard yet, but they're heading towards non-compliance. So you can catch them before they reach non-compliance with either a standard or worse, a regulatory requirements.
Merlin is the AI component to our PQ Canvas cloud-based power quality analysis system. Merlin analyzes data, it looks at every waveform, looks at every strip chart, and is analyzing every piece of data that comes into the utility, either through streaming or through uploads. And it applies a standards-based approach to classifying waveforms, judging severity, and is triaging and finding trends and patterns so that the utility engineer can concentrate on solving problems, not trying to find the problems in the first place.
Merlin delivers expert-level review in minutes, automatically scanning every waveform, strip chart, and event, applying IEEE standards, while surfacing the issues that matter. Merlin takes data a step further, turning it into actionable reports that engineers can use to quickly find and prove their findings.
It is well aware of how to use the industry standards in terms of power quality analysis, and has been trained on literally thousands of power quality files and petabytes of power quality data, so that it has a deep understanding of what to look for and what to bring to the service to utility engineers.
Rather than spend all of your time hunting through hundreds and hundreds of waveforms looking for that one standout that'll tell you what your problem is. You can spend your time working on the root cause, possible mitigation steps, and interacting with the customers.
By reducing truck rolls and resolving PQ problems faster, utilities reduce costs, and customers see stronger reliability and compatibility between their loads and utility power.
By spotting trends, it can identify where the utility power is edging towards an incompatibility or recognize equipment problems before they become failures, and this allows utilities to take a proactive approach rather than a reactive approach.
With the automated reports, they are based in the standards, not just giving you a pass or a fail, but they are giving you a picture of, are you approaching the thresholds? Are you trending in a good direction? Or are you trending towards crossing the lines?
AI will continue to play a transformative role in the power grid, improving efficiency, reliability, and the integration of renewable energy sources. Ongoing research from Power Monitors highlights how data-driven tools can support utilities as they build a smarter, more efficient electric future.